Hi everybody, so let's take a look at the beginning step-by-step problem for the Mathia for today. Okay, so this is the first workspace, which is on identifying key characteristics of polynomial functions. And so the first thing they're asking us is to determine whether it has any extrema. So those are the highs and lows, the minimums and maximums, either they're relative or absolute minimums or maximums, okay? And so if we look at the graph here, we basically have a parabola. And so there is an absolute minimum, so yes, there is an extrema. What is the point of that extrema? Okay, so we're going to look at it, and I can see right here, it looks to be about -2, 2. So we need the coordinates. So I'm going to type in parentheses, -2, 2, close parentheses, and I'm right. So a relative minimum is kind of the bottom of the valley, but it's not the lowest point on the entire graph. So this is the lowest point. This is not a relative minimum. So it says, well, their definition, and don't forget you can click these vocabulary words here. A relative minimum is a point where points immediately to the left and right have a higher y-coordinate. A relative minimum does not have to be the lowest point on the entire graph, although it may be. So do points immediately to the left or right have a higher coordinate? Yeah. But it is an absolute minimum. But we're going to go ahead and click say it's a relative minimum because it fits that definition. But we're also going to say that it is the lowest point on the graph. So we're going to say it's an absolute minimum. Okay, is there any other extrema? I don't think there's any more. That was the only one. So we're going to click no more. If there were more, you would continue to add them. Okay, look at the graph. We're going to look at the end behavior now. Okay. As x goes from -infinity to infinity, are the y-coordinates increasing, decreasing, both increasing and decreasing, or constant, so flat? So if we go basically left to right, from -infinity to infinity is a mathy way of saying left to right along the x-axis. It goes down and then it goes back up. So it is both increasing and decreasing. Okay, and now at this point, we're going to talk about the intervals of increasing or decreasing. So we're going to start with from -infinity to what is it? Well, from -infinity is all the way to the left, all the way down to, what was that, -2. And then that's where that vertex is. And then from -2 to positive infinity, it's going to be going the other way. So from -infinity to -2, that's the left half of this graph. From here to here, it is decreasing. And then from 2 to infinity, it is increasing. Okay, so decreasing, then increasing. Okay, so the end behavior is looking at the ends. And now this gets a little tricky because when you're talking about increasing or decreasing, you're looking from left to right. When you're talking about the end behavior, you have to follow the graph as it's saying. So when they say as x goes to -infinity, y will go to, so basically saying as we're looking at the graph, as it goes to the left, it's going up. So up would be up to a positive infinity. Okay, and then as x goes to positive infinity is talking about x going to the right. So as it goes to the right, y is going up also. So positive infinity. Okay, so those were the three kind of, well, we had to do the extrema, we have to say was increasing, we have to do the or decreasing or both the intervals, and then we had to do the end behavior. Let's look at one more problem. Okay, this time we're looking at some other characteristics. They want to know the number of y-intercepts and x-intercepts. Those are also characteristics. So looking at this graph, I can see there is one y-intercept, and there should only be one y-intercept at most, because if there's more than one y-intercept, it's not a function because it wouldn't pass the vertical line test. Okay, enter the coordinates of the y-intercept. It looks like it's at 7 or 8. I think it's 8. So we're going to go and say it is 0, 8. Push enter. Yeah, okay. Name the number of x-intercepts. I can see 1 right here at -2. There's only 1. And it's at -2, 0. Remember that for y-intercepts, the x is 0, and for x-intercepts, the y is 0. Okay, do we have any extrema? No. This is a cubic function. It basically goes up and up and up and down and down and down. It doesn't really have any extrema. This point is a point of inflection. So state a statement that describes the function. Let's see. Constant, continuously increasing, continuously decreasing, both increasing or decreasing, or is it constant? It is, if you read it, remember for this part, you have to read it left to right. It's going up, 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 almost kind of flattens out and then goes up, 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 up. So it is continuously increasing, and the interval is the entire time. So we would say from -infinity to infinity, it is increasing. All right, let's go ahead and take a look at the other Mathia workspace for today. Okay, so here we have zeros of polynomial functions. And this is a concept builder, but just remember that a 0 of a polynomial function is graphically, it's an x-intercept if it's a real number. And algebraically, it is the value of x that would make the function f of x is equal to 0. So for this part, you're going to go through a few slides and answer some questions where you are going to look at the zeros of the functions. Okay, so I'm going to leave you to do this one since it's a concept builder. It's just got to follow through it. Okay, all right. Good luck on your Mathia today, and also you'll see some notes that I linked for the last couple of sections that you had to do last week that could help you. All right, hope this was helpful. Bye.